Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to go over how to recognize and draw your optical isomers. We're going to use an example that I used in another video when we're talking about isomers of coordination complexes. So here we're gonna look at both the cis and the trans isomers to see if they are optical isomers or not. If they are optical isomers, and that means they are not going to be superimposable. So if you take the image, if you take the drawing and you take its mirror image, if you can rotate it 180 degrees and then superimpose it, then that means they're the exact same molecule, exact same complex. So there's no difference between the two. They're identical. They're not optical isomers. If you do have two mirror images of the structures, if one structure is the mirror image of the other, then they're not going to be superimposable. Then you do have optical isomers. So if the mirror images can be superimposable, they're not optical isomers. If they are not superimposable, then they will be optical isomers. So here's example number one. So here we have the complex here. We have here the, this is the trans isomer. If we look at the trans isomer, where we have the ethylene diamine on opposite sides, the chlorines on opposite sides, we take this isomer here. We then draw the mirror image of this. So this one is the mirror image of this one. And then if we take this one, rotate it along this axis 180 degrees. So this ethylene diamine will come over here. This one is going to come over there. You turn it, rotate it, and here it is. And you'll see that these two are indeed superimposable. They look exactly the same. These two are coming out. These two are going into the board. These two are coming out of the board. And so you can superimpose this one onto this one. So that means that they're both identical to each other. They're not isomers. They're not optical isomers. Okay, so what about the other isomer? So I'll come back with that one. Okay, and so here I have the cis isomer. So here with the cis isomer, we have the two chlorines on one side and the two ethylene diamines on the same side. So we do the exact same thing. We draw the mirror image. Here's our mirror, and we draw the mirror image. And so you can see the two chlorines on this side are closest on this side. And we have the top part. This is really important to see this. We have the top part for the ethylene diamine. We have the top here connected from the top to the one going in the back, right? So this is going from top and the back. This is going from, is binding top and towards the back here. So this dashed line means going into the board. So you can see, excuse me, this is the mirror image of this. And here you can see the bottom is connected to the forward one, bottom to the forward. And so, so we have our two mirror images. Now the next thing we want to do is decide if these two mirror images are optical isomers or if they are not optical isomers, meaning that they are exactly the same molecule, and so therefore they will be superimposable. If they're not superimposable, then they're different molecules and they are optical isomers. And again, what an optical isomer means is that what these two are going to be mirror images of each other and they're not superimposable, which means that they're going to affect light differently. So that's why it's called optical isomers. You pass light through it, and one isomer might turn the plane of light to the right and or to the left, or you might have the other isomer will turn it the same degrees but to the right. So So those are what we mean by optical isomers. So what we do here is then we rotate. We're going to rotate this 180 degrees. So 180 degrees, we rotate it 180 degrees, and then we compare these two. Are these superimposable? And it's hard to see at first, but what you can see now is when you turn this, this is into the board. This wedge here is going out of the board. But when you turn it 180 degrees, this is then come out of the board. So this will be out of the board. So right here. So this, when you turn it 180 degrees, is going to then be this one here. This is going to come out of the board. And this one, when you turn it 80 degrees, this is going to go to the back. So this one is going to take that spot, and this one is going to take that spot there. So you see that here. Now, the thing to keep in mind is, notice that here you have the top bonded to the back. But when you flip this one, you have the top bonded to the front. Bonded to the front. So that's key here. And the bottom here is bonded to the front. But then the bottom here is bonded or connected to the back. So these are not superimposable. They are shaped differently. They are structured differently. So therefore, they will be optical isomers. I hope that was helpful. If you like my videos, please like, share, subscribe, hit the notification bell, and make a comment in the comment section. Thanks for joining me, and I'll see you next time.